web APIs. I think they're incredible. And fortunately, a lot of people are really enthusiastic about web APIs, right? So APIs traditionally have actually a really long history. There was recently a very interesting case in which Oracle prevailed over Google around Java APIs. It's another kind of APIs. We can have an interesting discussion about that particular decision, but here when I'm talking about APIs, these are web-based APIs. These are APIs that typically will go over HTTP, for remotely connected systems with software providers and so on. Why am I so excited about web APIs? It started for me out of purely selfish reasons, and I think this is probably a very common thing. Developers are happy, are actually very proud of being very lazy. Back in the Perl days, right, it was one of the things that book preached, the Perl book, is be lazy in a creative way. Find ways to minimize the amount of work you have to do by all sorts of cleverness. And APIs are the ultimate buzz for creatively lazy developers because you get to piggyback on other people's work. You just call their API, they do all the work, and you just kind of leverage it. So the question is whose work? And when I first started getting excited about this was around 2004, 2005, and you could mash up Google Maps with something and Google Maps with this, and the only thing you had to mash up with was Google Maps, and it was kind of like, yeah, I understand it can one day take off, but it really wasn't. Fortunately, things have evolved since then. So if you look at just the number of public APIs today, this is Programmable Web, which is a daughter company, I guess, of MuleSoft. There's around 10,000 or so public APIs that are listed in that directory. And as we've noted, and I talked to someone else here, there's probably another 1 million APIs or so internal to various enterprises. So, you know, web APIs really have become not only a very large number of them, but they've also percolated in the sense that there's now pretty much an API for anything you might want to do. And so putting them together into interesting scenarios is actually in itself very, very interesting. And that's the other part, is that we have really reached critical mass. Pretty much anything that you want to do is available via an API, and usually via multiple APIs, and so you get some competition, which is really, really healthy for the marketplace. So they're taking off, they've reached critical mass, you can do a ton with them, and with that, of course, come a lot of problems, because now that there's all this stuff out there, how do you actually deal with it? How do you sort through it? I can tell you that if there's 10,000 APIs, there's probably 15,000 different ways of doing them. And that's largely because even inside these APIs, they're not internally consistent. So there's a lot of stuff that we need to do to make those APIs better, and RAML kind of comes at it from that direction. Now, lest you doubt that web APIs are actually important, I'll just make the case a little bit more. So they've really become front stage in business, right? So we are now driving a lot of our business, and our competitors are driving a lot of their business because of API needs. They've become kind of front stage in a lot of businesses. They are key to powering big initiatives like mobile. And mobile is a huge trend out there. There's a ton of budget associated with that. There are companies that are finding new revenues. One of our customers, New Zealand Post, is actually creating new revenue streams, because you know that the postal offices, revenue streams are going down, but they are finding new things to do with their capabilities by exposing them out as APIs. And innovation. So you put APIs out there and people figure out how to do amazing things with them. And that often can actually transform your business. And there's good case studies around that as well. Now, because big initiatives are being powered by this, they're now tied to business objectives. So I can't make my particular, let's say, qualified lead number without putting the mobile app up. Okay, so now it's really tied to my business success, which means there's somebody actually who's fought for a budget for these things, who owns these things, who wants them to actually succeed. They're not sort of a side effect of something that, oh yeah, I'll go expose my API. They actually are the reason why you make your money. And companies like Salesforce, for example, are getting most of their revenue through their APIs. So that's really large numbers. And in many cases, people are starting to regard their APIs as products. Box recently had an announcement that they've switched the way that they actually bill for some of their services to recognize that their API is now getting to be as important as their user interface. So a lot of changes happening behind these APIs. Now, I'm going to focus today on practically RESTful APIs. Pretty much web APIs fall into two camps. There's SOAP and there's REST, or REST-ish. And so what do I mean by practically RESTful APIs, and why do I focus on these versus SOAP? First is because we like to be kind of future-looking, so we like to anticipate things a little bit and kind of go into the things that are on the ascendancy rather than things that are going down. And even inside of enterprises today, this was not true 5 years ago, but even inside of enterprises today, SOAP is kind of seen as yesterday's story. There's still a ton of SOAP out there, But when you ask people, oh, you're building your next internal API, what's it going to be based on? More likely than not, they'll actually say REST. So that's one reason. The other one is if you're looking at public APIs, mobile APIs, new APIs, the things that often drive revenue, those tend to be REST. There's still a lot of B2B APIs and a lot of EDI and stuff that's happening behind the scenes that are going to be more SOAP or SOAP-like, but REST is really kind of seems to be the direction. And also REST is where a lot of the problems are. So it's the new direction for people. They don't necessarily know what to do with it. SOAP, for better or worse, is a known thing. Right? There is no innovation happening in that space. It basically is known and so on. But here there's a lot of innovation, a lot of learning, and a lot of problems that enterprises are having in trying to embrace these RESTful APIs. Okay, so what do I mean by RESTful APIs? It's basically APIs that are written down to the HTTP spec. You look at HTTP itself and you figure, you know, I don't need to dress this up with all sorts of other constructs like SOAP did. HTTP itself, as a protocol, already has a lot of the pieces that you actually want. So when you're modeling your domain, and after all, that's what an API is, you're modeling some domain so people can access it. The nouns are the resources described by URI paths, right? So when you go get a web page and it's something / users, you know you're getting something having to do with a collection of users. So the URI paths in HTTP give you the nouns. The verbs are the HTTP methods. You can get something, you can post a new thing, you can put or patch and update, and you can delete. And all of these things are encoded into HTTP. Metadata lives in HTTP headers, and there's a good, rich tradition of these are the headers that are expected, and this is the semantics behind those headers, and so on. And then the responses, and actually the payloads the responses themselves, the HTTP status code, there's a list of there's probably 100 or 200 that are in some use. And they're very well thought through. People know exactly what a 201 is and a 204 is. And people don't anymore, in the REST world, return to you a 200 when your request has actually failed completely and you have to dig into the response to look at what the error code was. If it failed, you don't return a 201. It's 400 or something, or 500 and so on. And finally, the representations, the actual payloads, are the bodies of the request or the response with the appropriate media type. So it might be text / XML, it might be application / JSON, those are the two most common ones, but there's other kind of media formats that are specialized for specific things. Now technically to be called REST, there's one other thing that you have to add to this, which is hypermedia, right? So if you look at the term REST, and you go back to Roy Fielding from which this came, Roy Fielding will tell you, well, it's not RESTful until you also have hypermedia. And it's not really the subject of my talk here, so I won't get into that very much, but it's a really interesting topic around what do you do to make something actually be hypermedia driven? The payload has to be not just a representation, but a representation that has inside of it the ways to get to other resources and the relationships between the resources. And in the case of HTML, which is a hypermedia format, it also gives you the controls by which you can change state. What I would say about hypermedia is it's definitely an area of interest, but it's quite uncommon to see APIs that are truly hypermedia based. So lots of people call it REST. What they really mean is HTTP without all of the SOAP extra stuff. So here, when I'll talk REST in the rest of this talk, what I'm talking about is something that has the nouns and the verbs and all of that stuff from HTTP, but need not actually have hypermedia as part of it. Right? So I'll kind of use the term loosely. I'm in pretty good company there. The vast majority of the world uses it that way. Okay. A few other things to set up APIs, and this kind of sets up the reason why I think RAML kind of came to be. So some interesting things that are driving the API economy or that are constraining what things succeed and don't succeed in today's RESTful API economy. So imperatives for success. The first one is the need for speed. People have gotten used to, or if you like, spoiled by the speed at which they can develop, the speed at which you can deploy, the speed at which new businesses thrive or fail. Everything else has to now be a lot faster. And so development cycles also need to be much faster. API design has to be much faster. This need for speed is actually driving REST itself. People didn't want to go through and learn and deal with SOAP. They just said, look, REST is so simple, I'm just going to go for it. The other aspect is developers really rule. It's no longer the case that you go to some CIO and he says, you know, I have imposed the following on my company. To a large extent, a CIO learns from his developers what are the things that are actually going on, And when that thing has kind of reached critical mass, it's like, oh yeah, well that's what we've standardized on. So it really is a lot more of a grassroots thing. And this isn't some apocryphal thing. We're seeing that out there. Mule started actually an open source product, and to a large extent, it grew because of traction that we got by developers directly. So developers really rule the world of APIs, and developers really love simplicity, which is another reason why REST has become so predominant. It's just much simpler, it's much easier to deal with. The other interesting aspect that's driving this is agile development. So people are doing a lot of agile, and here you run into an interesting conundrum, right? Agile will tell you, well, keep tweaking things, release quickly and iterate and so on. An API doesn't like to do that, right? APIs don't like to constantly be tweaked and changed. People rely on APIs, and they kind of expect them to sit there and maybe they're versioned, but they don't change all the time. So how do you reconcile agile development with APIs? And to some extent, I guess my answer to that right now would be, well, use agile development to develop your APIs, then lock down those APIs for a while. Think about versioning to begin with. And once you've got the API in place, you can do as much agile development on top of it and below it, but keep the API stable for a while. And then you can version it again. GitHub, for example, versions their APIs, it seems, roughly once a year, or once every 2 years or so. And they'll keep the old one around for about a year and then kill it. So, right, they don't also change their APIs. If you change your API continuously, nobody will ever build on top of it because they don't necessarily match the rate of your change. Okay. With those things in place, let me talk a little bit about some core concerns. What developers are actually going to when they're looking for REST, right? What do they all kind of run to and try to embrace? So the first thing is, what is the API? Like when I design an API, what does an API actually look like? I know what an implementation looks like, but what does an API look like? What is the API itself? What's the interface actually? Without having control of that interface, you actually don't exactly know what you're talking about. And for SOAP, again, we have WSDL that tells you what the API is, but what is the API in case of REST? Is it the documentation or is it something stronger than that? Once you've understood what is the API, how do you know it's going to work? So if I create an API, how do I know it'll actually be useful for people? Right? And that's just like a product. If you think of an API as a product, how do you know before you've actually built it and launched it that it'll actually work for you? So that's the second concern. Third concern is, if I've gone and designed an API and I've put all the effort into implementing it, I want to leverage in all sorts of ways. I want everybody to build on top of this. I want people to be able to know that it's going to work for them. I want to document use cases. I want to get as much mileage out of my API spec as I possibly can. So those are kind of, I boiled it down to these are the three core concerns. And the lesson that I learned out of that, or at least the hypothesis that we had when we came up with RAML is, if you get the core right, if you get the actual API spec right, everything will flow out of it. So if you've got a good API source code, the actual API itself has been nailed down, out of that you can auto-generate documentation. So your documentation is guaranteed to be correct because it's generated out of the actual API that drives everything else. In fact, as soon as you have the API spec itself, you can mock it. You can know already what the responses will be before you've implemented anything. And with this kind of automatic mocking capability, you can give people a live console to go make calls against the API before you've implemented the API. I'll show you that. You can also start to mock detailed use cases. And I'll design one here if I have time, hopefully I will, to actually make sure that this API, when you release it in the wild, will serve the purpose that you want. Usually you need to mash up that API with other APIs to get your work done. Well, once you can mock the API, you can actually verify that. And I'll do that here. If you've got the API, you can also start generating clients for it. So somebody on the mobile device wants to call your API, just give them a little library that already works for Android and iOS, and they can make calls very easily to your API. In fact, you can even start to generate your server. So you can actually generate stubs and minimize the amount of work that developers, remember they're very lazy, minimize the amount of work, the boilerplate work that developers have to do to validate the payloads and know what error codes to return. You can automate all of that away. And finally, you can test it. So API is the ideal surface for testing, right? It's a machine-accessible, well-declared interface into all the functionality that your consumer will ever care about. So it's perfect for testing. And in fact, it's the testability of this thing and parallel development that first got me into the field of API specifications when I was working with Martin a few companies back. So that was kind of the root for this thing. The other interesting thing that this gives you is actually lifecycle management, because you have something to manage. You can check your API into a source code repository and understand when it's changed. If all you're doing is checking your docs into source code repository, was the change a fix of a typo, or was the change an actually change in the API? But if your API spec is checked into source code, unless that source code system indicates it's changed, your API is not changed. So there's a thing to actually manage, and that gets into versioning and so on. The final thing that doing this actually does is it starts to actually help you get consistency of APIs. And that really depends on the spec format, but I think I will convince you that with RAML, you're kind of shamed into consistency. The way that this works is, when you document your API in something like RAML, if your API isn't consistent, it becomes long and bearish to document. And the more consistent it is, the more it starts to collapse on itself, because you don't have to repeat pieces. So if you have a very consistent API, you can actually extract all the patterns out of that, put them somewhere else, and write very, very concise APIs. Again, developers are lazy, so the more concise the thing can be, the happier they are. So it kind of drives them, right, carrot versus stick, into writing more consistent APIs. And if everybody were to do that, then instead of 10,000 APIs with 15,000 different patterns, we'll get to 10,000 APIs with maybe 100 different patterns. And that's a much, much better state to be in. Okay, so hopefully I've convinced you, or at least tantalized you, that the API source code is actually important. You can actually go better than that. You can actually start with the source code and not do anything else for a while and verify that that source code works. And that's API first development. So what it means is this, and by analogy here. If you start with the API and you specify what that API is, by analogy to building a house, you basically can tell the people who build the top and above the ground, this is what the foundation will look like. You should start planning to build a house given this foundation, right? Given these kinds of constraints. And the guys who are going to lay down the concrete for the foundation and so on, you can say, this is the thing you'll need to actually create so that the guys on top of the house can start working. And then they start actually implementing in parallel. And again, we saw this at work at eMeter. We've seen this again at MuleSoft. Both sides can build at the same time, knowing that the layer at which they will meet is well defined in advance. And so you can actually have or less your development time. And more important, you're guaranteeing that when these things are actually done, they'll actually work. Right? In cases where they're kind of all guessing at what the other side is doing, the chances of you actually meeting in the middle are actually small. But if you do API first design, you can get a lot more efficient and a lot more predictive about whether your API initiative will work. And remember, that's what enterprises are looking to do, because there's revenue tied to those APIs. Those initiatives have to work. So that's why API first development is becoming so popular inside of enterprises. So what are the steps to API first development? I'll be very short about this. First, you have to plan. You do have, and software is not going to help you here. What are you trying to achieve? Why do you even have an API? You do have to do that. Once you understand what you're trying to do with your API, you want to actually design it and validate that it's actually going to work for the use cases that you care about. Once you've locked down that spec, go ahead and implement it. You know what success looks like. That's what the spec is. You're just trying to meet that spec. And then you deploy it somewhere, being able to manage it, operate it, engage the developers with documentation and so on, all that kind of good stuff. And then finally, look to the next version, and now you have a way of telling your developers, hey, the next version is coming, because you can now deprecate it, because you've thought about versioning to begin with. I won't go through all of those steps. For RAML, I'll basically just go through one, the design and validation step, because I think that's actually the most interesting, and in some senses the most important. If you've got a badly designed APIs, I can point you to companies whose API initiatives have simply failed because consumers couldn't wrap their heads around how to actually go and consume this thing. Okay, how do you actually get to API success? You have to make your users really happy, right? I'm a big believer in sort of the consumerization of enterprise IT. If your users are happy, and in this case your users are the people who are developing against that API, if they love your API, you'll succeed. Look at Stripe, right? This company is just killing it in the recurring billing space, and to a large extent it's because they've embraced developers. They've come up with a really good API and a good API experience, and developers are choosing with their feet to use Stripe instead of their competitors. So you have to design the API for your developers. You have to model it very cleanly and consistently. You iterate quickly because you're never going to get it right first, so you have to very quickly get that feedback. And then you go and you do what you need behind the scenes, and finally you engage with them, right? So how do you get that sense of delight? How do you get developers saying, that's a really cool API experience? There is an analogy. You remember how user interfaces used to be called UIs, and now they're all called UXs, right? Because people care about the entire user experience. And the way they do that is they put something out there, get some feedback, iterate until they get the whole user experience right. Well, APIs, you can do the same thing. Something called an APX, Application Programming Experience. What is it like to get access to your API? What's it like to consume your API? Do you have awesome documentation? Do you have examples? Do those examples actually work? Do you generate the code, et cetera, et cetera? This great kind of APX, if you can go through that cycle of design just like you do with user interfaces, you'll get that reaction out of your users. And that's how you reconcile Agile with API development. You nail it in the design phase, and then the implementation becomes a lot more straightforward. So I'm going to talk to you more about API design here, and you'll just have to believe me that the implementation then becomes a lot easier. We can talk about that later. All right. So, API spec. Right? We're trying to have an API spec that's going to work for RESTful interfaces, that's going to get adopted by the same people who adopt REST. We're trying to get an API spec that will make it easy to design APIs, and something that will allow you to very quickly iterate through it. So without further ado, let me introduce RAML. There are other API specs out there. RAML is probably the most significant one that is new. So that was introduced last year. The RESTful API modeling language is a very simple way to actually model APIs that are RESTful. And again, RAML is not MuleSoft. There's a RAML work group out there. We're not calling it working group. It's the work group because we're not going after an official standards body yet, because that would slow things down. So we will eventually go to a standards body, but at this point, we've basically gathered people from a few other companies that care about APIs and are moving this thing along pretty quickly. If you want to find out more about it, just go to raml.org. There should be all the resources that you would want to care about there, and we can talk through that channel as well. There's forums out there and so on. So that's about RAML. Let me actually show you how RAML works. And the whole idea of RAML is it should be as easy as REST itself, right? It's trying to appeal to exactly the same people, right? The people who love REST are never going to go for WSDL. If RAML becomes WSDL, we will fail. So we need to do something a lot simpler than that. Okay. Here's how it can work. So let's say that you were to send an email to your friend describing a user management API. You'd say, well, you know, I've got this resource, users, and I can do a get and a post on them, and I can address an individual user in this way by addressing /user/user ID, and I can do these operations on an individual user, and I would email that to a friend of mine because he could read that, and it's pretty straightforward. So RAML makes it look like this. That's this RAML description of exactly the same interface. We're piggybacking on top of YAML, so white space is actually meaningful. And there's well-known YAML parsers out there, and YAML is optimized for readability, unlike JSON. So this is the RAML spec for exactly what you saw before. All it adds is a title, I guess the RAML version that this uses, and the version of this particular API. So it's got versioning kind of built into it. Exactly the same semantics as we saw before, but now in machine-readable, versionable format. Well, so the next thing that I want to do is I probably want to add some extra stuff. And I also wanted to remove stuff that is already obvious. Because these methods are used exactly the same way in all APIs, you don't actually need the descriptions. But I do need some query parameters on that get. So let me add some query parameters on that get. I've got a name as a query parameter, and the meaning of it is I'm going to filter by name. Right? So this is how you describe in machine-readable format a query parameter. So you do get /users ? Name equals. All that stuff is described in this way. And hopefully you're starting to see this is really simple to do. In fact, it's so simple to do that instead of having a RAML graphical designer, we just gave you an editor. You start typing. We'll see how that works. Now, you start to build out your API. I'm going to do one for you here in a moment. You build that out, and you build it out, and you start to say, you know, if I'm doing things right, I'm going to start repeating myself. Right? There's going to be these patterns that come out. And so what we did in RAML from step one is we gave you a way to express those patterns and extract them and externalize what we call refactoring so that you can actually have the same patterns applied over and over again. So the way a pretty rich API would go is the following. You would basically have schemas, resource types, and traits. I'll go through what those things mean. Schemas are what you expect. Resource types are the types of the resources, so they can be strongly typed. And traits are behavioral things. We'll see how those work. And so here what we've said is I've got a collection of users. So I'm going to give collections some meaning. I'm going to show you how collections behave. The type of collection is going to be of this particular schema, and RAML supports XML schema and JSON schema. It has certain behaviors. In this case, I've defined a behavior called secured. These are not built into RAML. These are things that you can go and define. But once you define them, you can use them over and over again. And here's another thing. This one is of type member, same schema, and is also secured. And once we breathe meaning into what it means to be a collection and to be secured and so on, then this actually becomes the complete specification of a very rich API. And that's what I'll show you in a moment. That's how RAML works underneath, and it's the only one out there today that actually supports these patterns. Now, it covers full HTTP, so there's other pieces to this. You can actually use this reserved parameter version to help you actually version that API. It supports full template URIs, so if you're doing more interesting things inside of the actual URI, you can do them here. We saw already query parameters. There's also headers for both request and response, and you can describe them like any other parameter. In fact, they use exactly the same syntax. So again, it's kind of a dry approach, a don't repeat yourself approach towards describing APIs. You get a different response per status code, so we're encouraging you to actually use these status codes properly. And you can include examples. Now, you can also include schemas, as I said before, but the examples are really the meat of it, right? Most developers love to read examples. They let the machine actually read the schema and understand what's going on. So RAML has all of that kind of stuff built in. Some examples of resource types. So in that previous one, what I showed you is a collection. Resource types are defined in exactly this way. So first is they're inheritable and they're externalizable. So in this case, I created some base behavior that has the resource, the sort of the archetype for all of these resources, and put it out somewhere. I can put it out on an absolute URL and just suck in the behavior. You can say, you know, I want a GitHub-like API, and if somebody's published the patterns for GitHub, I can just point to that, and your API will start looking exactly like GitHub. So I can externalize that, and then I can inherit this resource type. So you can see that collection starts from base and then adds things to it. So it adds, for example, certain traits. Every collection should be paged, right? And that gives me exactly the same semantic and the same syntax for all of my collections to use exactly the same kind of paging. I can also parameterize these things. So I can say, not only is it a collection, but it's a collection of whatever schema I pass in, and I can pluralize or singularize that to get the right semantics in there. I'll show you examples of how this stuff works. So you can define relatively powerful patterns with a very simple syntax like this, and then again, apply them over and over again, or even create pattern libraries if you like. Here's some examples of traits. One might be paged, that we used before. All that page says, in this particular case, is query parameters are start and number of pages. Right? You can define your own paging mechanism. As long as you put it somewhere, you can use it over and over again, and then you can publish it so other people can learn from it. Here's a searchable, and here's a particular example. If I say /books is of type collection, and it has a get method that is paged and searchable, it automatically will inherit all of these properties in the API. The RAML parser will automatically blend those together. You see, for traits, it's a mix-in model. So the RAML parser will put all those together, assemble it, and give your API that behavior, all that stuff. Okay. One other thing is schemas. They're not particularly interesting other than the fact that we support them, and these are kind of, it's a well-defined thing. We support XML schemas, JSON schemas. The only problem is that very few people actually know and use JSON schemas, but hopefully over time that will evolve. It's really the only standard you have for JSON today. So here's an example of one. Here's an XML schema, here's a JSON schema, and here's some examples that you can include. And if you just want to use form data, you can also use that. So use the schemas that are actually built into the World Wide Web that already have a lot of standard typing inside of them, right? So these are just name-value pairs that you would get in a normal web form. That's a perfectly good schema language as well. Very simple. Okay, so I'm flying through this so that I have at least some chance to actually get through the actual example. So here comes some keyboard time. The example that I wanted to show you is a lofty thing that I concocted over the weekend. You know, there's been some rumors that Amazon is going to start dropping packages in our houses for real-time delivery. So I figured, you know, let's beat them at their game. and came up with a company called Congo, which is the second biggest river in the world. And what this company is going to do is it's going to actually have a way to have drones flying around and pick up packages and drop them on your house and so on. Let's see how easy it is to design an API for the Congo company. How do I get out of this? Okay. All right, so I start with the RAML design. And RAML has a bunch of ecosystem, but so far this is the popular designer that happily enough my group ended up actually releasing. I start off with a completely blank RAML. And in this case, I'm going to call it API for drone deliveries. Okay. I think I need to make this big again. Here we go. So what you'll see here is that the API source code, the file is actually here. This is a little listing of other files. And you'll start to see an actual console that's documenting the API form there on the right. So what do I need for a drone-based API? The first temptation is, let's start putting a collection of drones. But that's actually going to be hard because you're going to need to tell every drone where to go and so on. The more realistic one is, I'm going to have a collection of deliveries. Right? So there are deliveries of things that need to get delivered, and then I'm going to let the back-end system figure out where the drones should go in order to actually make those deliveries. So let's start with that. I'm going to start with a collection of deliveries. And so this is a list of deliveries, and here I'm going to be able to address an individual delivery by its delivery ID. And that sounds great. So now I've got a way to do deliveries, and now I can go and probe the collection of drones to say, hey, which particular drone is actually going to be making my particular delivery, so I know what to look up for in the sky. So I'm going to put a collection of drones in here and be able to address an individual drone by its drone ID. Now, on a given drone, I should be able to ask, what are your deliveries, right? Where are all the places that you're going to go and deliver, and what are the packages that you will deliver? And to do that, I can actually use this exact same API. So what I'll do here is I'll put a YAML anchor. I'll call it something. I should probably spell it right. And then in here, I'm going to say that there's a sub-collection of deliveries. And the value of it is exactly the other one. Great. So I'm going to save. And with that, I've got the basic layout of my API, right? It's that simple. If I go here on the right, I can actually look inside of this console and start to see, okay, you know, it's looking like the right structure. There's no methods defined yet, so I really haven't done anything as far as being able to access this API, but at least I sketched out what the nouns are. Now I'm going to start to sketch out what the verbs are. So let me start with, got this all kind of lined up here. I'm going to start to define what can I do in a collection of deliveries. So one thing I can do in a collection of deliveries is I can go get it. And you see that it's already helping me actually autocomplete that because it knows where I am in the tree, and so it's going to start helping me with the possible syntax. There's also this handy dandy shelf under here that always tells me what I can actually do, but I've done this for a year now, so I've started to memorize what these various things are. But if you're just starting out, you can just click on these things on the shelf and they help you complete it. So I can get the list of deliveries. I can also create a new delivery. That's usually going to be through a post. So here's the post. And let's see, that's probably all I can do. I'm not going to be able to delete the entire collection of deliveries, but I can delete an individual delivery. So on an individual delivery, I've got a get. I've also can update an individual delivery. You can use patch, you can use put. The right semantic for partial updates is actually patch. And I can delete it. So here I've got pretty much an entire CRUD on a table of deliveries, right, in SQL language. Well, nicely enough, again, this thing is actually starting to flesh out rather nicely. So I can do a post, and it explains that there's a request and response and so on. Now, again, I haven't flushed out any of those details, but you can see that it's getting in that direction. Let me show you what it looks like when you flush out a few more things. So after I put in all the methods, it starts to look like this. Right? Again, nothing that surprising. I've just lined up what all these various pieces are. And now I'm going to start putting some flesh into here by telling you what are the responses and what are the HTTP status codes. And it looks like it's all very linear, but I can tell you this is a whiteboarding session. You sit there on Caltrain for an hour and you start to puzzle out, well, should it be like this or should it be like that? You're modeling, but you have a place to actually do the modeling. In fact, you can do more than just do the modeling. I'll show you what this does for you as you start to model this stuff. So, next iteration after this, I'm going to actually rethink one of these things, because it turns out that I should not be able, this is one of these typical kind of thought experiments, right? Because I had the same capabilities on this guy as I had on this guy, it means that, for example, I can go and create a new delivery directly on a drone. Now that actually won't make any sense, right? I should not be able to tell a drone, make this delivery. I should be able to add something to the collection of deliveries and let the back-end system figure out which drone is going to pick it up through some optimization. So I'm going to go ahead and change this, and actually, I'll just show you where it ends up. Just actually make the /deliveries explicit. I'm going to give that one a different API, a read-only API, instead of actually trying to copy-paste different pieces of the API. And the only reason I did this is to show you that this is an iterative process. You never get this right quite at the beginning. You sit there and you model this stuff. You'll see how you get a little bit of help in modeling this in the next step. So now I'm going to start adding query parameters, and just to save time, I'll just show you what those query parameters end up looking like. Right? So I could type them, it helps me type it, but here's what they end up looking like. So query parameters for deliveries, let's be able to say I want all deliveries starting from a given date and ending on a given date, and you can have a type of date, and you can give examples to this stuff, and it's starting to get fleshed out. How about the drones? I should be able to ask, what are all the drones within a given location? I can give GPS coordinates for this thing and give me all the drones within 100 meters or 1,000 meters of this particular one. And I'm really starting to model out what the domain is starting to look like. And then I say, you know, this is pretty cool, but what I'd like to do at this point is I'd like to actually play with this API. Well, how can I play with this API? I haven't implemented it. Yeah, but I know what it's going to end up looking like. Since I know what it's going to end up looking like, I should be able to mock it, right? Now, I'm going to do one other little thing here. I'm going to add a little bit more examples, because mocking is really interesting when you've got some example data to actually play with. So let's do that. If I look at this next step, I'm going to look at the bodies and at the responses. Right? So for each one of these methods, there might be a response. So there's always a response, but there might also be a request body. So here what I've done is I've said, okay, here's the collection of responses. And in the collection of responses, a 200 will have a body that has the following as an example. And I just put the JSON right inside of here, because YAML is actually a superset of JSON, so you can just put JSON right directly inside of here. So here's the example of what the list of the list of deliveries might look like. Right? And again, I'm just typing this stuff out, modeling, creating one, copy-pasting, changing it a little bit, just like you normally would. But it's actually all machine readable, all well-defined. And in fact, what I can do here is start to explore these things. Let's look at what adding a delivery looks like. Right? So I can see here that it's got a description. It knows its application JSON. It knows that here's a particular example of this body. And what I can also do is I can start literally creating that API. So all I did here was to turn on the mocking service. What the mocking service did is it said, oh, this is the API that you want? No problem. Let me go and create a mock implementation of that API on a server and offer it to you at a particular URL. So now notice the base URI was added automatically. And you can actually curl this particular URL and get exactly the API that we just defined. In fact, let me show you how this works. Let me open this up a little bit. And now we can actually try to add a delivery. I'm going to pre-fill this thing with an example. Let's go ahead and post to this URL. Running, running, running. I get back a 201, which is the right status code for a creation. And sure enough, it returns to me, here is the particular ID of the object that was just created. I haven't implemented anything, right? I'm just at the mocking layer. But it's a very simple design surface to actually create design APIs and go test if it actually works. Because I can publish this particular console to a developer portal. You can do that on our platform. And give that to the developers who are building the mobile app and say, hey, is this going to work for you? And they're going to start being able to actually make requests against this and say, oh, no, you know, we're missing this parameter, or this thing is too complicated, and so on. And you start to collaborate with them and design this thing without writing a line of code. All right, so that's pretty cool. But if I look at all of this API, it's getting to be a little bit big. There's a lot of pieces to it, and all of them are necessary, but they're a little bit repetitive. So now let me refactor this creature. So what I'll do here is I'll start to pick up the common patterns, right? So one thing is I'm going to come up, now that I know what the examples are, I'm going to work backwards and come up with the right schemas and put them all in a schemas file. And I'm going to refactor the common behaviors and put them in a traits file. And I'm going to refactor the resources. They all look like a collection and a member and a collection and a member. I'm going to go and define what a collection and a member actually mean for my API and factor that out as well. And then see what the refactored API actually looks like. Let's take a quick look at that. So I've created a couple of traits here. Paged is just this, right? It's what we saw before, right? It's got a start and it's got the number of pages. So on top of the query parameters I had before, I'm now going to add some paging. And I figured out something that every enterprise needs to do, track who's actually using that API. Because all sorts of departments will sneak in more and more usage on your internal APIs. And unless you're able to track that, you're not going to know who's actually consuming your resources. So we're going to add another trait called accountable. We're going to require that every API call puts in a header called the accounting code. And you can actually put an enum here to actually put the valuable departments that can call your API. And this will actually get enforced because the required is equal to true. So here's a couple of traits you might want to use. With these traits, I'm going to define my resource hierarchy, my type hierarchy. Base resource is going to be accountable, so all my resources that inherit from this are going to require that header. Here's what a collection looks like. It's going to inherit from this. It's going to always have a get and a post, right? All my collections should have that. Get the collection, create a new item in the collection. And a get looks like this. Again, nothing particularly interesting here. It's all the stuff that we've said before. Well, I've even got documentation that's auto-generated. Because whatever the resource path name is, /users, /drones, /deliveries, will automatically turn into get a list of users, drones, deliveries, because it's a pattern. And I've got schema here. Now, how does it know what the schema is? Well, I'm going to use convention over configuration here. So in this API, my convention is that if I have something called /deliveries, there will be a schema called deliveries.json. And that's how I know that this schema will actually exist. And similarly for the examples. You'll see how I pass in those parameters if they're not convention-based here in a moment. So I have a get, and I have a post, and I have a member, and so on, and I've encapsulated all this, and I only need to do this once. Over and over again, I can use exactly the same pattern. All right, so with that in place, I can also go back and encapsulate the schemas. So here's what JSON schemas look like. It's JSON, so it's a little bit crufty. It's got extra stuff. People have been asking us, why don't you allow us to write JSON schemas in YAML? Because you can get rid of all the quotes, you can get rid of all the curly brackets, and everything just becomes a lot simpler. And we may add that to the next version of RAML. But that's what the JSON schema looks like, that codify what you saw before as the examples. All right, so with these three things, here's what our API ends up looking like. The entire API is this. And it's a really rich API. In fact, this one is already mocked, so we can make calls against this thing. Fully documented, fully machine readable, documentation already auto-generated for you. You'll see a few more things that this actually gives you. But it's actually pretty simple, right? You could email this to somebody and they can go and actually understand exactly what your API is doing. It's readable, right? It's human readable as well as writable. And the only thing that I've added in here, and I've collapsed it here, is these various examples, right? So what's an example of a new member? What's an example of an entire member, and so on. And here I'm passing them in as parameters to my collection. Remember, the collection had some parameters. Here I'm just giving you the actual values of those parameters. So an example member to this collection has the following example. Okay? So that's kind of the gist of what we're doing in creating API designs. Now, to show you a little bit that this is completely reusable, my use case is not just that there are deliveries and drones, but what is it that these things are actually delivering? Items. So I need also an API for orders and order items. And you're like, oh God, he's going to take me through all of that story again. No, I'll just show you the end result. The end result is actually surprisingly simple and surprisingly familiar. Here is a complete e-commerce API, well, an orders API, that does exactly the same thing with a collection of orders and an individual order that contains a collection of items that contain individual items. And the same patterns are used over and over again, so the entire API is specified by this. Right? So these big old APIs that have all of this kind of behavior that you see here on the right are captured in these very simple ways. And in fact, here I've literally reused exactly the same patterns that I had in the deliveries API. So you can imagine a big enterprise, Cisco, has thousands of internal APIs, and they can all use exactly the same pattern libraries and get some consistency across all those crazy groups that are doing APIs. All right, so without much further ado, I wanted to actually show you how we verify that this API has just been designed on Caltrain on the way here, kind of, and that has been mocked, right, without any implementation. How do I know it's actually going to work for my use case of dropping packages on your roof? Well, the way that I would figure it out is I would start to go script out some actual scenarios. So for that, we created something called the API Notebook. If you go to apinotebook.com, it'll redirect you to this crazy URL, but it's just apinotebook.com. So API Notebook came out of a personal frustration that I had, again starting at eMeter, where whenever I had a mocked API or any kind of API, how would I actually verify scenarios? I'd open up a browser tab, I'd make a call to the API, I'd copy paste the result, open up another browser tab, paste it into that, make another call, and I'd script out these 5 or 10 different scenarios, and then I have to do it over and over again. There's no way to actually share that with someone. Plus I have to constantly think about HTTP, and I don't really want to do that when I'm scripting out scenarios. So API Notebook is a way to get rid of all of that. And if anybody's ever used Mathematica, it's inspired very much by Mathematica. I used to use it when I was a physicist. Python has a notebook concept like this as well. Here's how the API Notebook works. You go and create a new notebook. I'll go ahead and create a new notebook right here. So it starts out blank, and you can say, you know, I'm going to go and use a particular API. Which API? I'm going to actually look for the drone API. So here's the Congo drones API. And all you're doing here is you're pointing the notebook to a RAML spec for that API. And what it does is it says, oh, this is your API, no problem. Let me generate a JavaScript client for you right here. Right? You don't have to go and read the documentation for that API, because you can start typing the following: Congo drones demo dot, and it knows that you've got deliveries and drones. So here's deliveries. And it knows that deliveries has a get method on it. And when I call that get method, guess what's going to happen? It's going to go and make the API call and come back with a body and headers. And here's the body, an array of 3 things, and here's the first one. And sure enough, there's my example, because my mocking service is simulating my API. All right, so this is pretty cool. So let's start to run through some scenario, right? How do I actually want to use this API? First thing I want to do is I want to create a delivery. And once I've created a delivery, I'm going to come back. The first thing I want to do is I actually want to create an order, right? I have to have something to deliver. So I'm going to create an order. After I've created an order, I'm going to get the list of order items and all their prices and all that good stuff. I'm going to take one of those order items and I'm going to schedule it for delivery. So I'm going to post it to the deliveries collection, and it's going to come back and say, okay, you've just created the following delivery. The backend optimization will run and will say, here's your delivery ID. I'm going to go get that delivery ID and ask, okay, which drone is going to be making that particular delivery? And then I'm going to tell the user when to expect a particular drone to land on the roof, deliver a particular package, right? Now, if the API was badly designed, I'm going to find some flaw in that. I don't have the ID, or it doesn't get returned, or the name of the drone doesn't come back, or something like that. But now I can actually verify the entire thing. So let me actually show you what that looks like. Here's that entire thing written out. So first thing, I've created this guy, and I've created one also for the orders API. And remember what I did before is I just went and ran that particular one. Now I'm going to place an order. So placing an order is just using exactly this kind of syntax, right? Here is, I don't know if you guys can see, I'm going to post to the list of orders the information necessary. And again, the autocomplete, I'm just running short of time, so I'm going fast through this. The autocomplete will help me actually complete this request. And when I actually place that order, it comes back and says, no problem, here's your order, right? With an order ID. Now, I can submit that order ID and get the order items. So I'm going to make an API call and come back with these 3 order items, right? That's what was in my example. So that's looking pretty good. Now, the items to deliver are, I'm going to just arbitrarily choose the first one, just so I can model this out. So here's a particular thing that's going to get delivered, right? It's going to have this particular catalog item and the description, and here's the price of it, and so on. And now I'm going to schedule this item for delivery. So the way I'm going to do that is I chose which one to actually deliver, and then I'm going to post it to my deliveries API. And when I come back, notice all the information that's there. So if I didn't read all the documentation, I can still figure out exactly how this API is working. Remember, I'm making this seem like I thought of it in one fell swoop, but the reality is I played with this for a while until I kind of got it to all work. I can go back and change the API. The mocking service keeps up with every character that I type, continuously changes the API behind the scenes, and I can go and rerun this until it actually works. So now, with this particular drone ID F, I can go say, well, tell me more about this drone F. Okay, it's the one that's called Camelot. That's interesting. It's going to have a big red Camelot on the bottom of it. And now I can say, okay, how do I know that I have all the information to actually tell the user what to expect? Well, let me just see if I have the information. Well, I've got the drone name, I've got the description of the item to deliver, and I know exactly when it'll actually be delivered, right? So that's going to be the actual message that I'll be able to send to the user. And just to kind of have a little bit more fun, let's go and actually send this to the user via Twitter. So I don't remember the Twitter API, but we have a RAML file for it. So let's go and create a client for it. I'll just point it to the RAML description of Twitter, and comes back the Twitter API. Now, this API is actually secured. And by the way, I forgot to mention that RAML also does security schemes, so you can declare OAuth, you can declare password. There's a number of security schemes that it supports. In this case, it knows that authentication is going to require me to actually authenticate into Twitter. Does an OAuth handshake. I've just authenticated into Twitter. And with that, I have an authenticated client, and I'm going to just update my Twitter feed with the status of this message. I'm sending it out. Comes back with a 403. Not a happy puppy. Why does it come back with that? Let's see. Gives me some array. Let's see what Twitter says. Status is a duplicate. Okay, I'll tell you what. Let me change this. Expect. There we go. So now it's not going to be a duplicate. It's already authenticated, so now let me tweet that. Great. 200. Success. It tells me all this interesting Twitter information. I couldn't care less. The whole thing is being saved automatically. What I care about is whether it actually tweeted that message. So let me go over to my Twitter feed and refresh the page. And sure enough, here's my expect with the colon. So it's actually a full worked out scenario between multiple APIs that I've designed for you on the fly here, and a real live API mashed up into it without touching code, because the code I would have had to do is the whole implementation. Of course, that comes later. But at least I've verified that if I go and build the deliveries API, the drones API, and the orders API, I will actually be able to execute the transaction that the user is actually looking for, and that this API is actually useful. So it's going to delight the people who consume it. So hopefully they'll use Congo and not Amazon to actually do their deliveries. Okay, that's the overall idea. Interesting thing about this API notebook, the entire thing is actually Markdown. There's no actual code in here. If you actually look at what a source code of a notebook is, it's just a bunch of Markdown with fenced code blocks. And because it's Markdown, we actually save it automatically as a gist to GitHub. So as you're developing more and more of these notebooks, they just get saved automatically to your GitHub account, and you can manage them as you want. In fact, it's also really simple to actually publish them to another web page. So once you've come up with a few usage scenarios, just stick them in your blog page or stick them wherever you want, and people can go and actually see this. Here's a very simple embedded notebook in an HTML page that just contains a body and the notebook tag. And it's all live. So you can actually hit play at the bottom, and every user can go and tweak their own version of this thing or can play around with it. So these notebooks are very, very shareable as well, which encourages people to go and embrace your API as well. Okay, I think I have 4 minutes here until the extended time runs out. But all I want to encourage you is to go ahead and check out RAML.org. RAML's picking up a lot of traction, so we've got by far more projects that were built from people outside of the core work group than inside. Whole bunch of conversion tools and parsers in various languages, and hopefully you find this not only useful, but you also join the community and start to contribute You can just search on GitHub for RAML-related projects, and there's just a ton of these things, and they're starting to multiply. So it's getting some critical mass as well. And I should stop and give you at least 3 minutes for questions. Thanks, everyone.
I have a question.
Yeah.
So two groups develop two APIs. How RAML can be useful here?
If they're completely different APIs,
No, they interface to each other.
one that's calling the other.
Anyway,
So the interesting thing about these APIs is they are the consumable side. They're not the kind that actually calls together. But I'll give you a very simple example. If you have, for example, two partners. So New Zealand Post is a great example, right? It's another customer. They have an API that helps you do addressing. So they'll verify the addresses. They'll actually give you postage rates and so on. They have a partnership with Kiwi Bank that actually does the payment handling for these things. Now, Kiwi Bank can expose an API that it doesn't know yet whether it's going to be useful for this kind of combined solution. But New Zealand Post can go and consume that API even before it's actually implemented, put it together with their API, work out that the scenarios actually work out, and then they can go and actually finalize that API. Now, so RAML makes that design, collaborative design, really easy.
To accept in one direction. Export. I want to export and redefine and how it will work.
To export what?
To allow the team.
To the same thing. Okay, so what you probably want to do is, there's two kinds of export. One is you actually want to engage them with your API. And to that extent, you use RAML and some of these tools to create a developer portal, to create an API console, to create scenarios with notebooks, and you publish all of those inside of a developer portal. Hey, come and see how this works. The other thing is you should publish your patterns, because whatever patterns you've discovered for this thing are likely going to be useful for someone else as well. Those are kind of the two methods.
Thank you.
Yeah.
Are there conversion tools? Say an enterprise wants to get with the new way of doing things, and of course they have legacy hundreds of APIs.
Absolutely. Here's a Swagger to RAML tool written by somebody who got tired of waiting for us to write the conversion tool between Swagger, which is one of the spec formats, and RAML, so they wrote their own. We're now writing, literally this week, a general purpose conversion tool that uses templates. And so you'll be able to have Swagger to RAML or back, and Waddle to RAML and Blueprint to RAML. Those are kind of the well-known ones. And actually, because it's a general templating tool, you can do a lot more than just converting back and forth. You can actually auto-generate clients as well. So if you know what a typical, say, iOS client for a RESTful API looks like, you can templatize it, and then any RAML API can be used to auto-generate an iOS client for that API. So that's the direction that stuff is going. Every week or so, a few more of these things appear. Yeah?
So it's nice to see how the auto generation, you're really reusing the same thing, you then generate other things. So can you just clarify for mocks? So you're really using examples, you provide examples, and then mocks use those examples to generate?
Yep. Let's, shall I prove it to you? We can make a change to the example.
Okay.
Let's go do that. Let's make a change to one of these examples. Let's change the name of the list of drones. So this one, I'm going to call it High Flyer ACM. Okay? And I'm going to go and get the list of drones back here at the bottom. So let's see. I can execute this guy again. I think this is the guy that I need. And insert here a, where do I want to put this? I want to insert a code cell here. I can do deliveries API dot drones dot get, and look at the body. 2 came back, and ooh, look at that. It did not change. Why did it not change? It should have changed.
Next
Very good question, right? No, this version should. Oh, which one did I do? No, this one. I did the right one. It's the example collection of the 2 drones, right? High Flyer ACM. Run this one more time. And this one I'm going to be smart about it. I'm going to actually do dot body. Nope. It looks like the mocking service is not responding to this thing. So I've failed on my demonstration. Don't quite understand.
So it's using caching.
Well, the mocking service is not turned on, is it? It's there.
It is turned on, but I think I copy pasted it here. Yeah, I think you're right. I think that's what happened here. So let me actually delete this. Now I'm going to turn on the mocking service again. Now it will follow, and we will go and verify this in just a moment. Let me go and create the client again so it realizes where it's getting the mocking service. It goes into the RAML definition, and run this again, and there it is. Awesome. Thank you, Martin. Now let me make one more change to make sure that it's still happening. Let's call it ACM2. I'll make this call, and there it is. Okay, so it's live. That's how it works. Yeah.
So you have an example of a collection, and you also have an example of a member of a collection.
Yep.
And those are independent examples. So a member will not necessarily be a member. And also you cannot mock, or can you mock addition, deletion, insertion, that sort of thing.
You can mock. Remember that you're not really getting semantic in here. So you may delete as much as you want from the mock, but if you get the collection, it will not have changed, right? So it's not faithful in that sense. JSON itself could support pointers, so you could actually reduce the verbosity of some of those things and make sure that an ID that you used in a collection can be used in the member and so on. But the parser right now doesn't support that. So what I did instead in some of these examples is I just used YAML pointers. What you'll see here is instead of repeating the example for the delivery, I basically just put an anchor to it, and then I refer to that here, so it will give you exactly the same example here and here. So I'm taking shortcuts where I can, but not sort of inside the JSON. That's a little bit more than JSON itself can support. If I were using a different hypermedia type, I could actually point to something. Yeah?
Yeah, how does RAML handle the versioning?
So it's funny, RAML encourages you to version without telling you how to version, right? So it encourages you by having a defined root level property called version, where you're allowed to put in whatever string that you want, and then allowing you to use that property inside of other places, typically in the base URI. So in that sense, it gets you to think about versioning at the beginning. The trick to versioning is not so much that it's hard. Most people just don't do it. They don't bother. They think that it's a hard thing, and so they don't bother at all. And with RAML, it's just intuitive to just call it something. Call it V1, right? And that way, at least you have a way to refer that when this thing changes again, you'll call it something else, maybe V2, and you'll start to deprecate your V1 and have a place to already do your V2. Just helping people think through that process is already a huge step forward. Versioning is really an indication that you're going to probably keep the two versions alive at the same time and slowly deprecate the old one while moving all the traffic to the new one. And to do that, you have to have a way to refer to the new one. So obviously there could be lots of complications in an enterprise scenario where people have been relying on your old one, and how do you communicate with them? But again, because we've generated all this useful stuff like documentation, and we give you a way to automatically generate a developer portal and a way to register applications against that API, you've now established a communication channel with your consumers. And so you can warn them. Companies like GitHub do that. They warn them and say, hey, you've got 12 months to migrate to this next version of the API before the old one goes away. And then we give you API management to start to throttle the actual traffic to the old API to kind of force people to move to the new one until you finally shut it off completely. Yeah.
As a consumer, I can imagine using this to define an API that I'm consuming.
Yes.
Maybe so that my team.
That's right. It's a
has
PRD
something
for
to work with.
APIs.
Yeah, and so I wonder if you have any features or tools specifically focused from that use case of RAML, maybe like verification that I've actually documented correctly the behavior of the API that's already implemented.
So that's actually interesting. Is there a way to actually verify that the API that you've documented is indeed the API that's implemented?
Right.
We have a team now that's building that's capturing a few public APIs in RAML to make things like Notebook easy. They're the ones that captured the Twitter API and so on. So they've built some behind-the-scenes tooling to help them capture those APIs. But I told them that, I'm not going to rely on that. I want you to actually create a notebook that exercises the entire API, all the possible, the reasonable number of combinations of that API, and pulls in an assertion framework, Chai.js is the one that we chose, to verify that when you do a post of this data to this particular resource, the thing that comes back has indeed the properties documented in that RAML. And so they now have a tool that auto-generates that notebook. A human then has to go in and give it the semantic, right? That in order for me to delete something, I had to have first created it and so on. Right. So they actually put that, and then the notebook becomes the continuous integration tool against that API. You can keep running that notebook, and as long as the assertions have actually worked through that, then you know that the RAML has actually described that API. And we're working on a much more dry approach to testing APIs coming soon. Anybody wants to work on that with me, by the way, I'm thrilled to have your help, because it's actually hard to document all the test cases for an API without repeating yourself over and over and over and over again. So finding a way to collapse that is the current mission that we're working on.
So
yeah.
You mentioned a couple of times that you're not really capturing semantics. So what are your thoughts about doing it at some point? Because, for instance, we just mentioned like there's a lot of repetitive steps.
Yeah.
If you have the right meta information, captured semantics, then you could automate those things as well. So
yeah, I think it's a little bit of an open problem. I don't think anybody's really managed to describe the entire semantics of an API. I think hypermedia go some way towards that, because at least they give you the relations. They don't actually give you the operations you can perform. They just tell you this is related to that, but they don't say that these are the methods that if you perform them, you will get the following result. So I think they go some way towards describing more of the semantic, but I don't know of a way to actually fully capture the semantic of an API. In my mind, it's still an open problem, and so it's a field of research, I guess. I think when we do that, there will be a more compelling reason for people to use hypermedia than there are today. Yeah.
How do you see the stuff like this changing? I mean, perhaps more broadly, but perhaps more narrowly, the mule business. Did you see it changing the business?
It has changed our business already. Because we've adopted this and because we've kind of advanced the design-first approach, there are a lot of companies that want to instill better governance of APIs as they build out internal APIs. They start to offer external APIs. And so as a result of that, they've actually chosen us over other vendors, because we don't just manage the APIs, we actually help them with a full API lifecycle. So companies are a little bit more forward-looking, are doing exactly this kind of thing. There are other reasons why companies would choose us for API management, all the integration capabilities we have behind the scenes. So I don't want to say this is the number one reason necessarily, but it's been a major driver for our business. It's also let us create our own internal infrastructure much better. So we have a strict API policy that all the user interfaces that you see for MuleSoft are always built as single-page apps on top of well-documented externalized APIs. For us to be able to do that, we try to do as much as possible API-first design ourselves. We use our tools, we make sure that it actually works, and we're actually in the process of releasing the next version of our API platform built in exactly these principles. So it's helped us internally as well. But to a large extent, I think it's the fact that we've been able to show, along with other people in the work group, that there's a better way to do APIs than people have done before that have led people to kind of go to us for the rest of our solutions. Does that answer that question?
Yeah. Well, let me ask one more question.
Yeah.
That was you. The same thing could be applied more broadly? I guess the adoption varies and points of view vary, but...
Yeah, I mean, we have a competitor, a very nice company, SOA Software, that also offers an API management space. They've just joined the work group. They see the traction that RAML is getting, and they want to kind of embrace that and offer tooling for RAML as well. There are other companies that I should not be saying in a public sense, but there are also very large companies in this space, some competitors, some partners of ours that are embracing RAML. You'll see there's a person from Cisco who's just joined the RAML work group. I don't have him up yet. So in that sense, I think this approach is starting to spread pretty largely.
Is there something, question. Is this in some sense agile for messages or?
I think it's the agile for APIs, or at least as agile as APIs are likely to get, right? For something that is supposed to be long-lived, it's about as agile as you can get. It's agile in its design, and it helps you version it. In that sense, I think it's agile. It's also sort of requirements definition driven design. right? Which is another kind of best practice where you try to understand what it is that you're actually building and have some iterative way of testing that this is actually going to work before investing the big time in implementing it. So, you know, the implementation may still end up being effectively waterfall because you've already committed to a contract and now you have to go and actually implement it. So in that sense, you know, there's a big moment at the end where it actually works. But because you can mock some of it, you can actually do agile delivery towards that API, where you mock a piece of it, you implement another piece of it. The same tests that were working before on the mock had better start working, and now you keep adding tests to them that actually exercise the semantics. So you can actually use this for agile API development as well.
Thank you.
Yeah.
You mentioned API lifecycle support. Can you talk a little more about what that means?
Yeah, APIs are born and APIs die in the most pedestrian sense. So when it comes time to hatching a new API, this helps you design it and make sure that that API has a reasonable chance to actually work in real life. And then as you actually deploy the API, your API gateway can read the spec and actually do interesting things with it, like apply policies at an individual resource level and modify the spec dynamically in real time if you change, say, the security scheme that you apply to a particular resource. And then it can help you on the engagement side when you take that API live, obviously with documentation and examples and all of that good stuff. And finally, because it helps you in versioning, it helps you kind of gracefully end of life this API and move on to the next one. And that's what I mean by the API.
Thank you.
Yeah.
Are you guys providing training and certification? Are people putting it on their resumes that they have this skill set?
That would be another milestone, you know, certified RAML something. You're right, we haven't gotten to it. We'd love to, and it shouldn't be just MuleSoft. It should be anybody who's kind of in the RAML ecosystem should be able to offer this thing. So we just happen to be particularly delighted by this stuff. But I'm sure there will be consultancies and so on around this. So. And again, if anybody wants to do that, we'd love to have it.
I was wondering, is there a way of like looking at the log files and try to generate some sort of, you know, baseline, you know, someone who already has an API?
Yep. Absolutely. Wonderful question. We had a hackathon last fall. We have probably 2/3 of our developers down in Buenos Aires, another third up in San Francisco. And so we had a hackathon, 24 hours, where people got to build whatever it is that they wanted to build. And one group actually built a RAML sniffer. So they sit there and they monitor HTTP traffic for a while, and then out comes a RAML description of that traffic that is relatively compelling. We haven't productized that yet, but that would be really, really cool. The first 80%, really easy to do. The last 20%, absolutely impossible, because something that happens once a week, good luck getting it out of the sniffing. But that's where humans come in, and then you do the last 20%, and yeah, it would be an awesome tool when that's productized. Or maybe somebody else, again, wants to do that first.
Are you able to generate test suites for this type of API derived from the file?
Yes, and that's what I was saying before. We kind of auto-generate the notebooks right now, or we have tools that allow us to do it. I think there should be a much more robust way of generating all of that. So you can test, you can submit obviously payloads and see that the thing that comes back. What you can't do automatically, and that's what I was talking about, the semantic of this, is chain these methods, right? You can go and issue a delete against something, but really a real test suite would go and create it first and then try to delete it. There's nothing in the spec that tells you that the delete is related to the create. And so without that, it's actually hard to auto-generate all those tests, but what we can do is we can generate basically a bunch of tests and then make it easy for humans to add the rest of them. And that's what we're working on.
When you do tests, it's a bit of a systemic issue that you have to initialize your SUT in order to be able to do it. So
right.
Even though it's not specific really to WRM, it's kind of a bit of normal.
Yeah, it's the typical.
To set up the system.
That's right. So we have to give an affordance to go and set up all the data behind us and so on. And because this model is pretty much any domain, it's, you know, the only affordances we have is through the API itself. For example, if you create a read-only API, you're not going to be able to create the test system to go and change it. So there'll be some limitations.
How about auto-generating a simple GUI?
For?
Given this API, you can generate an administrative GUI.
Yeah, it's right here.
Sure, but against the live system. This is meant more for documentation, right?
It is. Well, it's more than documentation. I guess maybe I forgot to actually show this one. If I expand this guy, and let's say I actually do a post, I don't know, I think I showed this. you have a full GUI here in the sense that you can actually try the API, right? You can pre-fill it with an example, you can post, and you can actually use that. Beyond that, it's hard for us to actually know what is the domain in which it makes sense to model this beyond HTTP request.
Well,
So
you can take the schemas and use the JSON schemas or the XSD schemas
Yeah.
and generate some form fields with that.
yeah, and in a sense, I mean, that's kind of what we're doing, right? So
Yeah.
not so much in the post, but if you look at the get, for example, right? If you do the try it, we actually generate, here's a form field for pages and the synth state and start, and we show you the examples as kind of blueprints for these things. But what I'd really love to do is for somebody to say, oh, I'm in the insurance field, here's the kind of GUI that I'm interested in. And for that, there's this project that somebody started. It's called RAML to HTML, but it's actually much more than that. It's a general template generator. So you can start putting in the templates, not just for any HTML, but the specific HTML that makes sense for your domain, and generate automatic GUIs for anything that you have an API for.
Funny, I happen to be in the insurance industry and I have a good idea what my EY wants to be.
I should hook you up with somebody that's really in that space, and we should talk about that. It's really interesting. Yeah?
Yeah, question for capturing your design history, like why you did something once. You mentioned versioning is already done for you. So as you go through these mocked APIs, someone else takes over and says a year later, hey, let's do this, and then you go back and say,
Yep.
oh, but we tried that halfway through, and in the evolution, this is why we didn't do that. So do you have areas for meta comments?
You can put inside of your RAML, because it's basically sitting on top of YAML. You can put in YAML comments and leave some detritus behind that somebody can go and read and say, okay, this is why they actually did this thing.
Thinking of teams,
Yep.
there was a core team of 5 people that started, and suddenly you've got 100 people.
Yeah,
And they've all got bright ideas, but they don't understand why
Absolutely.
the original people went a certain direction.
so the real answer to your question is what we haven't done yet, and what we need to do is integrate this with source control systems. And at that point, you'll be able to actually, we have actually companies that are doing it, but they're doing it kind of themselves. There's a company called 8x8, it's a big hosting provider, and they're using RAML internally for one of their projects. And the way that they've evolved their APIs is through email. They've just been emailing, can you change that parameter, and so on. And now they've started to use RAML, and they're the ones who actually got tired of us and generated that Swagger to RAML converter. So they check in their RAML into their source control, and then they use git blame, and they use history and all of that to actually show the evolution of those APIs, and all of that stuff is captured inside their source control.
Email works fine if it's IMAP,
Yeah, you're right, but with git blame, you can actually see exactly who changed what and why and
Yeah.
all of that stuff. So there are systems out there for doing that with general source control. That's why I emphasize that it's so important to capture API as source code, because then you can apply that entire methodology to it.
Thank you.